Hello everyone. I hope everyone is good. So we are talking about chapter number one, physical world. In last lecture we discussed about scope of physics, excitement of physics, physics in relation to other branches, and physics in relation to technology. Today we are discussing about the most common thing in physics which we are going to study in day-to-day life, that is force. Force आपने पहले भी पढ़ा है in your lower classes. What is force? The basic definition of force is a push or pull upon an object. Either I am trying to push something or either I am trying to pull something. Right? The force is nothing but a push or pull upon an object, or we can say force is the external agent that produces motion. Right? It is an external agent that produces motion. Like if I am trying to push, if I am trying to push a bicycle, right? So that is a push, and the bicycle comes into motion or tends to produce motion. Like if a bicycle gets punctured and I have to go to the nearest puncture shop, then I am moving the bicycle with the force, right? But if I am using car, if I am using truck and I am trying to push the car or trying to push the truck with my own hand, then do you think it is possible to push the truck or a car? No. Why? Because the force required to push the truck or a car is much more than the force given by me. Right? So either it will produce motion or it will tend to produce motion. My tendency is to take the car to the nearest puncture shop, right? But it is not in motion. So either it is a tendency to produce motion, or it produces motion, or it stops motion, or it tends to stop motion. Like if a kid is riding a bicycle, some small kid is riding a bicycle, is coming towards me, then I am trying to stop with my own hands. The bicycle can be easily stopped because the amount of force I am applying is quite more than the amount of force the bicycle has, right? But if a truck or if a car comes and if I'm trying to stop a truck or if I'm trying to stop a car with my hand, that is not possible, right? So either it stops motion or it tends to stop motion. This is nothing but force. In basic thing we can say force is nothing but it is a push or a pull. Force is a push or a pull upon an object, or force is the external agent that produces motion, the one which produces motion or tends to produce motion, right? My tendency to produce motion, but it will be motion or it will not be motion. That depends upon what I am applying for. If I am applying force on a truck, then it won't be in motion. If I am applying force on a bicycle, then it will be in motion. It stops motion or it tends to stop motion. If I am applying a force on bicycle, it will stop. But if I am applying a force on truck, it won't stop. Right? But my tendency is to stop motion. So that is also a force. Now, generally, force is of two types. For two types, we have classified the force into domains. It is macroscopic and microscopic. The one which is visible with our eyes are microscopic, which are day-to-day life. Like if you talk about force in day-to-day life, if I am standing in a queue, I am standing in an assembly, or I am standing in a line to buy tickets for theater movies, so what we do? We try to push the person in front of us. Hey, chalna, jaldi chalna, kya kar raha hai? That force which I am applying is coming through my body, is coming through my muscles. That force is nothing but muscular force. What are force we experience more? Frictional force. If you are riding a bicycle, if you are riding an Activa or whatever bike, like what we do when we are about to reach the destination, we switch off the ignition. Right? ऐसा बहुत बार हुआ है, like if I'm about to reach the destination, we try to stop pedaling the cycle, or we switch off the ignition. Then it goes slowly, eventually it stops. Right? At the speed of 40, if I switch off the ignition, then it won't move with the speed of 40. Eventually it will decrease to 30, 20, 10, 0. Right? Why the speed is decreasing from 40, 30, 20, 10, 0? Because of frictional force produced between the tire and the ground. That force is nothing but frictional force. Right? If I drop a marker, it will go to the ground. Why? Because Earth is trying to pull the marker towards it, because it has mass and Earth also has mass. Whatever object has mass that has a tendency to pull other object, that is nothing but my gravitational force. Right? We discussed about it. Then it buoyant force. Whenever like in winter season, whenever we have to go to school in morning, like बहुत ही आलस आता है, then mom tells us go fast, फटाफट नहाना है, brush करना है, then we go to bathroom, what we do, we try to mix the water, right? Then what we do, we play with water, we try to insert the mug inside water, then the mug comes, right? हम क्या करते हैं, पानी के अंदर मग को ऐसे डालते हैं और मग ऊपर आ जाता है वापस, पानी उस पे एक फोर्स लगाता है, the water produces a force on that mug, that force is nothing but buoyant force, this phenomena is called buoyancy, and we try to put the mug inside water, but the mug again pulls the mug, when the water again pulls the mug outside it, that force is nothing but buoyant force, and the phenomena is called buoyancy, राइट? ये करते ही रहते हो, सुबह सुबह जाते हो, जो मेरे टब के अंदर जो पानी भरा रहता है उसके अंदर मग वी ट्राई टू इंसर्ट द मग एंड द वाटर पुल्स द मग आउट, that force, the water with the force that water is applying to pull the mug out, that force is nothing but buoyant, right? Then the next one is viscous force, which you see in day-to-day life. Like if I try to drop a marker or a ball in air, then in air, मान लो it will take 3 seconds. If I am trying to drop a marker in air, try to drop a ball from terrace, then it will reach the ground in 3 seconds or maybe 5 seconds or 10 seconds. Let us suppose it is 3 seconds, right? Then I am dropping the same ball, but not in air. I am dropping the ball in a container that contains water, right? Now how much time it will take to touch the ground? It will take the same time or it will take more time? Obviously it will take more time. मान लो उन्होंने लिया 5 seconds. It takes 5 seconds when we are trying to put the ball in a container containing water, right? Then if the container is containing oil or container is containing honey or oil, and if we try to put that ball in that container, then it will take 3 seconds, 5 seconds or more than 5 seconds. Obviously more than 5 seconds. Let it be 7 seconds. Why there is time difference? I am dropping the same ball from the same height. First I dropped in air. The first one was nothing but air, then water, and let us take a hand. In first container it was air. It took 3 seconds to reach the ground. Okay. In the second container it was water. It took 5 seconds to reach the ground. Why? Because water is applying a force, a frictional force upward. Honey takes 7 seconds. In honey, the ball or the marker takes 7 seconds to reach the ground. That means the force applied in honey is much more than compared to water. The force applied in water is much more than compared to air. This force which applies on the ball is nothing but viscous. Viscous force, nothing. Viscosity we will study in chemistry as well as physics when we are studying fluid. Class 11, chapter number 10. We will study fluid. We will study about viscous force. It is nothing but a frictional force that one layer try to oppose another. Right? We will
इलास्टिक फोर्स, you must have seen a spring, right? Toys में spring use होता है, पेन में spring use होता है. When we compress the spring or when we stretch the spring, और जब हम force को release कर देते हैं, it come back to its original shape, right? The tendency of the spring to come back to its original shape is nothing but elastic force. The next is electromagnetic force. Whenever we are sitting in the drawing room hall when we are watching the television, हम remote पे button press करते हैं and the channel gets changes in television. Right? मैं तो अपना force remote पे apply कर रहा हूँ, but this force is transferred into television due to electromagnetic waves. The electromagnetic waves is responsible. जब मैं यहाँ पे remote का button दबा रहा हूँ, the channel gets changes. This force is nothing but electromagnetic force. Then comes the magnetic force, right? Everybody has seen a magnet. North poles attract south poles and north pole repels north pole, right? Magnet attracts a piece of iron. This force is nothing but magnetic force. And there are many kind of forces in macroscopic forces which we deal in day-to-day life. But it is not possible to study all these forces one by one because there are majority of forces, hundreds of forces which we see in day-to-day life. If Earth revolves around the sun, right? That is another kind of force. Moon revolves around the Earth. That is another kind of force. A marker is when I drop a marker, it goes to the ground. That is another kind of force. But in science, in physics, we have the two major trusts in physics, that is unification and reductionism. In unification, what is our major target? To unify things, to derive everything in minimum laws as possible. Like it is not possible to remember all these forces. So what we did, we try to reduce all these forces, we try to find out the source. So all the macroscopic forces like elastic forces, magnetic forces, frictional forces, these all forces are nothing but electromagnetic force. हमने उसका source find किया and the source is nothing but electromagnetic force. Similarly, जो marker को drop कर रहा हूँ, gravitational force. When Earth is revolving around the Sun, that is nothing but gravitational force. Moon is revolving around the Earth, that is nothing but gravitational force. ऐसे करके ये सारे forces जो thousands of forces है, जो macroscopic forces है, that is defined by two major forces, that is nothing but gravitational force and electromagnetic force. So in macroscopic forces we have two fundamental forces, that is nothing but gravitational force and electromagnetic force. These all are the macroscopic forces. When we talk about microscopic forces, micro which are not visible with our eyes, we have seen the structure of atom, right? At center we have nucleus in which we have positive charged proton and it is surrounded by electron which is revolving around the nucleus. Inside the nucleus there are certain forces which are not visible through our eyes, which are not macroscopic forces but are microscopic forces. There are two types of force which is inside nucleus, so it is called nuclear force. Nuclear force, and there are two types of nuclear force. One is strong nuclear force and one is weak nuclear force, right? So there are four fundamental forces in nature. Microscopic forces and macroscopic forces are the two domains. In macroscopic forces we have gravitational force and electromagnetic force, and all other forces are from these two forces only, right? They are subdivided into these other forces, viscous force, buoyant force, frictional force, molecular force, elastic force and Coulomb force and many other forces. But there are two main forces, gravitational force and electromagnetic force, and all other forces come into this. Right? In microscopic forces, we have two forces, that is my strong nuclear force and weak nuclear force. So there are four fundamental forces: gravitational force, electromagnetic force, strong nuclear force, and weak nuclear force. So we'll see one by one. Right? First, we will start with gravitational force. Fundamental forces in nature. The very first one is gravitational. Right, gravitational force is nothing but the force of mutual attraction between two bodies. Two bodies which are having mass attract each other. That is nothing but gravitational force. That is, mass is responsible for gravitational force. Without mass, there is no gravitational force. Right? It is a long range force. Like, what is the range of gravitational force? 10 meter, 1 kilometer, 1000 kilometer. So the range of gravitational force is infinite. Infinite, like Sun and Earth, they are also attracted by gravitational force. That is why Earth revolves around the Sun. Moon and Earth is also attracted by gravitational force. That is why Moon revolves around the Earth. So it is a long range force. It is the weakest force in nature. Out of all the four fundamental forces, gravitational force is the weakest force in nature. Right? It does not need any medium. Right? If the medium is air, if the medium is water, or even if there is no medium in space, there is no medium, there is vacuum. So gravitational force is applicable there also. It does not require any medium. Right? This is nothing but gravitational force. Degree of macroscopic force is nothing but electromagnetic force. Electromagnetic force. Charge is responsible for electromagnetic force. When we talk about charges, there are two types of charges. One is positive charge and one is negative charge. Positive and negative attract each other. That is, unlike charges attract each other. And positive as well as negative and negative repel each other. Repulsive force. Right? Unlike charges attract and like charges repel each other. Now, electromagnetic force is stronger than gravitational force. जैसे कि अगर if I am writing a chalk on a blackboard, if I am writing something like physics, the chalk particle gets stick to the board. That is why the physics is visible to you. अब chalk particle जब board से stick होता है, the earth is trying to pull the chalk particle down. Right, but that small particle is sticked with the board. that is nothing but electromagnetic force which is stronger than the gravitational force. For example, this marker, I am able to lift this marker. अगर मैं इस marker को छोड़ दूँ कहाँ चले जाएगा? नीचे, right? But I am able to lift this marker up when the whole earth is trying to pull this marker down. That means my force is greater than gravitational force. That force is nothing but electromagnetic force, right? It may be attractive or repulsive. If it is positive and negative, unlike charge, it is attractive. It is positive, positive. Like charge, it is repulsive. It is a long range force again. Electromagnetic force is a long range force. Infinite is the range. There is no short range forces in macroscopic forces. Does not require any medium like gravitational force, electric force, or we can say electromagnetic force does not require any medium. It is 10 to the power 36 times stronger. See, 10 to the power 36. 1 के आगे 36 0. This much times stronger it is than gravitational force. So electromagnetic force is much stronger than gravitational force. So this was about macroscopic forces. Now we talk about microscopic forces, that is strong nuclear force and weak nuclear force. When we talk about microscopic forces, we have two forces, that is strong nuclear force and weak nuclear force. When we talk about strong nuclear force, inside the nucleus it is the strongest attractive force which bind together two protons. If we talk about inside the nucleus, we have positive charge proton. Now, in electromagnetic force we have studied that positive and positive repels each other. Then how these two positive can stay together inside a nucleus, right? So there was one more force which was a microscopic force which was not visible in our day-to-day life, but it was much stronger than electromagnetic force. It is 100 times stronger than electromagnetic force. Such force is called strong nuclear force. The strong attractive force which binds together the proton and neutron in the nucleus is called strong nuclear force, right? Now, this is a short range force. The range is inside the nucleus, that is 10 to the power minus 15. If it goes out of this range, then the force becomes repulsive, right? It is a short range force which operates over the size of nucleus, that is 10 to the power minus 15. It is the strongest force in nature. In nature, this is the strongest force, much more powerful than electromagnetic force and gravitational force. It is 10 to the power 38 times the gravitational force, right? So this is nothing but strong nuclear force between the two proton, or you can say about two neutron, or a proton and a neutron. When we talk about the second microscopic force, it is nothing but weak nuclear force. This is between the elementary particle. You study in class 12 nucleus chapter. And when we take beta decay process takes place inside the nucleus, elementary particles like neutrino emits out. The neutrino, the force between two neutrino inside the nucleus is called weak nuclear force, which is stronger than gravitational force but weaker than electromagnetic force and strong nuclear force. So it is called weak nuclear force. If the force appears that only between the elementary particle nucleopause, that is beta decay nucleus, it operates through range of nuclear size. The range is nothing but 10 to the power minus 15. Inside the nucleus, this force is applicable. Outside the nucleus, if the distance increases more than 10 to the power minus 15, then this force is not applicable. Weak nuclear force is 10 to the power 25 times stronger than gravitational force. It is stronger than gravitational force but weaker than electromagnetic force as well as strong nuclear. Now, generally it comes in exam, how much time the electromagnetic force is stronger than gravitational force, how much time the weak nuclear force is stronger than the gravitational force, how much time the strong nuclear force is stronger than the electromagnetic force. So you have to remember this ratio. If you talk about gravitational force and weak nuclear force, 10 to the power 25. Talk about gravitational force and electrostatic force, 10 to the power 36 times. Talk about gravitational force and strong nuclear force, 10 to the power 38 times. We talk about electrostatic force and strong nuclear force, 100 times. 10 to the power 36, 10 to the power 38, that is 10 to the power 2, 10 to the power 2, that is 100 times stronger than electromagnetic force. Right? Then you have to remember this ratio. This was nothing but the fundamental forces in nature. Macroscopic, we have gravitational force as well as electromagnetic force. In microscopic, we have strong nuclear force and weak nuclear force. Out of all the four fundamental forces, strong nuclear force is the strongest force. Then comes electromagnetic force. Then comes weak nuclear force, and the weakest of all is gravitational force. Right? And the last topic of the chapter is conservation of energy. Conservation principle. So let us see what is conservation. Conservation laws, right? In physical process involving the different forces, some physical quantities remain unchanged with time. कुछ ऐसे quantities होते हैं जो time के साथ changes नहीं होते. It remains constant if it's about 1 year. 10 साल बाद भी देखो, the quantity remains constant. Such quantities are called conserved quantities, and the laws which govern this conservation of these quantities are called conservation laws. Such quantities, ऐसे quantities के ऊपर हमने जो laws बनाया, these are called conservation laws. Like the first law states that law of conservation of energy. Energy can neither be created nor be destroyed. It can only be transferred from one form to another. Like if the marker, I have placed the marker over here, right? अब मैं यहाँ से अगर मैं छोड़ता हूँ, this marker at this position it has potential energy because it has height, right? A marker, if I drop the marker from here, the potential energy gets converted into kinetic energy, right? After the kinetic energy, there comes a sound. The kinetic energy is converted into sound energy, and when that marker falls, the temperature of that place is changes slightly. That sound energy is converted into heat energy, right? So total energy of the system remains constant. Like for an example, if there is a system, आपके घर मान लो एक system है, and you have 4 boxes to store coins, right? And the boxes are A, B, C, D. Okay. In box A, you have stored 15 coins. In box B, you have stored 10 coins. In box C, you have stored 20 coins. In box D, you have stored 5 coins. Right? And the total is 50 coins. Now, after some time, what you do is you change the coins in all the respective boxes. In first coin, you have kept 20. That is, in A it was 15. Now you have kept 20 coins, removing from these, and these. In B, you have kept 5 coins. In C, you have kept 10 coins, right? And in D, you have kept 50. In A it was 15, now it is 20. In B it was 10, now it is 5. So you have changed, you have converted the coins. In A it was 15, now it is 20. In C it was 20, now it is 10. But the total coin is 25, and 25 and 25 is 50, and here also it was 25 and 25 50. That is the 50 coins. The energy, total energy doesn't change, but the number of coins in each gets changed, right? So such thing, energy can neither be created nor be destroyed. It would be same all over the universe, but it can be transferred from one form to another. Like a fan use कर रहे हो, in fan हम switch on कर रहे हैं तो electrical energy जा रहा है, the electrical energy gets converted into mechanical energy of the form, but total energy of the system remains constant. We are just using in the form of energy, change कर रहे हैं हम electrical to mechanical, chemical to electrical, and other form we are changing, right? So energy, law of conservation energy states energy can neither be created nor be destroyed. It can only be transferred from one form to another. The second is law of conservation of linear momentum. Momentum is nothing but it is the product of mass into velocity, right? The product of mass and velocity. जैसे बंदूक, गन फायर करते हैं, राइट? तो मोमेंटम ये बोलता है कि मास और प्रोडक्ट की वेलोसिटी इट रिमेन्स कांस्टेंट विद टाइम. इनिशियली आपका गन और बुलेट दोनों रेस्ट पे थे. जब आप स्ट्राइक करते हो तो आपको बैक फायर होता है, राइट? जब भी आप बुलेट को स्ट्राइक करते हो, गन चलाते हो, बैक फायर होता है. क्यों? बिकॉज द वेलोसिटी ऑफ बुलेट इज मच मोर, but the mass of bullet is much less. The mass of gun is more, so the velocity of backfiring is less. The total momentum, we talk about momentum, P is equals to mv, where P is my momentum. The product of mass into velocity remains constant with time. या आप आगे वाले चैप्टर नंबर 5 जब laws of motion पढ़ेंगे तब इस चीज को आप डिटेल में पढ़ोगे. What is momentum and how it is conserved, right? So we will see later on. Okay, this is just a description in physical world what we are going to study ahead in this chapter. Then comes law of conservation of angular momentum. Like in linear motion, the rotational motion, when you talk about rotational motion, you talk about angular momentum. The angular momentum is also conserved. This you will study later on in class 11, that is rotational motion chapter number 7. Law of conservation of charge. A charge can neither be created nor be destroyed. Like in a system, if there are 50 charges and the charges get exchanged into them, but total charge of the system remains constant. That is law of conservation of charge. We will study this deeply one by one. From next lecture, we will start with our physics, that is chapter number 2, units and measurement, and it is the start of our physics from the basic, that is units and dimension. Right? So this was chapter number 1, physical world, the introduction to physics, introduction to the world of physics. Right? So I hope everyone is good and enjoying at their home. Thank you everyone.